Okay, so guys, what we're going to do now is, for the first time, if I'm not mistaken, really in your maths career, we're going to prove some theorems in Euclidean geometry. So in the last couple of lessons, we said that a parallelogram, which is basically a quadrilateral with two pairs of parallel sides, we know that the sides, both opposite sides are equal and both opposite angles are equal. I just told you that, but I didn't prove that to you. So what we're going to do, we're going to prove it to you, and you are required to be able to prove that in a test. So I can ask you in a test, given a parallelogram, prove that the opposite sides are equal, or the opposite angles are equal. Okay? It's a skill that we learn. Proof is a huge part of maths and geometry as well, which is part of maths. So the trick here is, and the trick with some of these proofs is that you get something like that, and then you suddenly, you don't really know straight away, but you have to figure out that you need to add something to that drawing. So we have to add a diagonal. In a test, you won't be given that diagonal, then you just have to add it. Okay? Now, the basic of all these proofs that we're going to do, now there's 3 of those theorems that we're going to prove, is to prove congruency of triangles. So we've got 2 triangles, and they look identical, isn't it? They look identical. Okay? Now, we know one, so you know these 2 triangles, okay? We know one side which is equal between these 2 triangles, which is AD equal to AD, right? AD obviously equal to itself. It's a common side. Okay? So now I'm looking for angles that are equal. So I need to give some numbers here. We'll give it 1, 2, 1, 2. Okay? Which angles are equal here?
D1 and A2.
So A2 equal to D1, because they are alternating angles, and remember we have to write down which sides are parallel. Okay, A2 and D1. Okay, it's AB parallel to CD. We all right with that? Okay. Then the other pair of angles that are equal are A1 is equal to D2. Okay. Again, alternating angles, but this time the parallel lines AC parallel to BD.
So isn't...
I'll just pause here for a second, yeah? Okay. Right. So, just to confirm, okay, we don't know that angle A is equal to angle D. That's what we want to prove. I know I told you that last time. Now we're proving why are these angles equal. So we know that this is equal to that, and that is equal to that. And we know that side is equal to itself. At this point, we can prove congruency. We can say that triangle CAD, I have to be careful about the letters here, is congruent to, help me out?
So it's meant to be CAD.
CAD, alright, there's not CAD. CAD is congruent to triangle BDA. Okay, why BDA? Because angle A, in that triangle CAD, I'm looking at angle A is equal to angle D2. So the middle letter here has to be D. Okay, right? Okay, and the reason, obviously I have to give a reason. The reason is SAA. Correct. One side and 2 angles. Alright. What do I do now? Okay, at this point I can say, okay, look, angle A, looking at the big angle now, is equal to angle A1 plus angle A2. Guys, this is lawyers we speak. You guys are lawyers, you should be good at this. Okay? So angle A, the big angle A, is A1 plus A2. Okay? I don't need to justify it. Obviously A is made out of A1 and A2. And angle D is equal to D1 plus D2. Okay, I need to, I'm just going to pause here for a second. Okay, so angle A and angle D. Now, if I know that A1 is equal to D2 and A2 is equal to D1, you see I've proved that. Okay, A1 is equal to D2 and A2 is equal to D1. Therefore, angle A is equal to angle D. Okay? which is one of the things I want to prove. Ollie says, but I didn't really need to prove congruency of these triangles. I already got it before. So you're right. You're right. For this case, I didn't really need to show that these triangles are congruent. So if I want to just show that angle A is equal to angle B, I don't need to this congruency. But I also want to show that angle C is equal to angle B. And for that, I definitely needed the congruency. And then I also can say, so I can say that angle C is equal to angle B. Why? Because I need to rewrite that as a statement. Triangle CAD congruent to triangle BDA. Okay? And therefore, I've got a situation. What I proved is that opposite angles in parallelogram are equal. Okay? I showed that that is equal to that, and that is equal to that. Okay, I'm just going to pause here for a second. There's a little bit of confusion, so I'll just maybe explain again. What my aim was, okay, to prove that in a parallelogram, opposite angles are equal to each other. To prove that, okay, I need to prove that this angle is equal to that angle, and that angle is equal to that angle. Okay, I need to prove it. So by finding these angles, or drawing this diagonal, and saying that this angle is equal to that, that is equal to that, then I realize that that is equal to that. But now I still need to show that these two angles are equal. And that's why I have to show the congruency. When I know that these two triangles are congruent, then these two angles are also going to be equal. But now I'm not really finished. The second bit I want to show is that it's not just the opposite sides that are equal. What else is equal? Not the opposite angles are equal. What is also equal? Opposite sides. Okay, so I'm giving the answer. And again, for that reason, I'm going to use the congruency. Okay? How I'm going to use the congruency? Well, I can say straight away that AC is equal to BD. How do I know that AC is equal to BD? Because they're congruent. Not because okay? Look at this. These two triangles are congruent. So AC is equal to BD. Got it? Once I realize that these two triangles are congruent, well, what does that mean? That means that is equal to that. Okay? AC equal to BD. Because, and I'm going to write it again, triangle CAD is congruent to triangle BDA. Okay? And which side AD is equal to? CD. And you can put it here as well. AB is equal to CD. Okay? So I can also say that AB is equal to CD for the same reason. Okay? So my aim, just to finish up this video, my aim was to show two things. That opposite sides are equal and opposite angles are equal in a parallelogram. I started with a parallelogram, I drew that diagonal, showed that these two triangles are congruent, and from that I proved all those things. I'm going to pause here for a second. In fact, I'll make another video for the next theorem.